Hello everyone, welcome to Passnownow preparatory class for physics. And today, we'll be looking at repeated questions in the past questions. Our first question is taken from the year 2012, number 15. In an X-ray tube, an electron is accelerated from rest towards a tungsten target biased at a potential of 33 kilovolts. Calculate for the electron the kinetic energy and the velocity, given that our h, which is the height, is 6.6 times 10 raised to the power minus 14. Our mass of electron is given as 9.1 times 10 raised to the power minus 3 kilogram. Then our specific heat is 3.0 times 10 raised to the power 4. Our electron is given as 1.6 times 10 raised to the power minus 19. And our volts is given as 33 kV. The first question is to calculate the kinetic energy. And our kinetic energy is given as Ke is equals to electron times volts. And we're given our electron as 1.6 times 10 raised to the power minus 19. And our volts is equals to 33 kilovolts. Converting our 33 kilovolts to regular volts, that is 33 times 10 raised to the power 3. We have 5.28 times 10 raised to the power minus 15. Therefore, our kinetic energy that we're asked to calculate is equals to 5.28 times 10 raised to the power minus 15. Times 10 raised to the power minus 15. Our next question, we have to calculate the velocity. To calculate the velocity, 2 times our kinetic energy divided by the mass of electrons in square root. That is 2 times 5.28 times 10 raised to the power minus 15 divided by 9.1 times 10 raised to the power minus 3. 5.28 times 10 raised to the power minus 15 multiplied by 2. Dividing 1.056 times 10 raised to the power minus 14 divided by 9.1 times 10 raised to the power minus 3 will give us 1.052. The square root of 1.052 equals to 1.025. Therefore, our velocity is equal to 1.025. Let's take a quick rundown at the whole question. We have to first of all calculate the kinetic energy, which is the electron times the volts. And now we are given our volts as 33 kV. Converting into volts is 33 times 10 raised to the power 3. That is times 1000. That is 1.6 times 10 raised to the power minus 19 times 33 times 10 raised to the power 3, which gives us 5.28 times 10 raised to the power minus 15. And therefore, our kinetic energy is 5.28 times 10 raised to the power minus 15. The second question was to calculate our velocity. And to calculate our velocity, it is 2 multiplied by the kinetic energy divided by the mass, the square root. After imputing the parameters into the formula, you have 1.025 as the velocity. Our next question is taken from the year 2011, number 8A. An electron of charge 1.60 times 10 raised to the power 19 coulomb is accelerated under a potential difference of 1.0 times 10 raised to the power 5 volts. Calculate the energy of the electron in joules. To calculate the energy, we have E multiplied by V. And our E is given as 1.60 times 10 raised to the power minus 19 multiplied by our V, 1.0 times 10 raised to the power 5. We have 1.6 times 10 raised to the power times 10 raised to the power minus 14. Therefore, our energy in electrons is 1.6 times 10 raised to the power minus 14 joules. Our next question is taken from the year 2010, number 7A. An X-ray tube operates at a potential of 2,500 volts. If the power of the tube is 700 watts, calculate the speed of the electron striking the target, given that our electron is 1.6 times 10 to the power 19 coulombs, and the mass of the electron is 9.1 times 10 to the power minus 3. We have our given to be, we have to calculate the speed of the electron striking the target. To calculate the speed, EV is equals to 1 over 2 mv squared. To make our v that we're looking for, that is the speed, the subject of the formula, that is 2ev is equals to mv squared. To make this v the subject of the formula, we have to divide both sides by m. This is 2ev divided by m is equals to mv squared divided by m. It is v squared, therefore v squared is equals to 2ev divided by m. So bringing it here now, we know that our speed is equal to 2 times 1.6 times 10 raised to the power minus 19 times v, and our v is equal to 2005 times 2005 divided by our m, which is 9.1 times 10 raised to the power minus 3. So 2 times 1.6 times 10 raised to the power minus 19 plus 3.2 times 10 raised to the power minus 19 times 25 divided by 9.1 times 10 raised to the power minus 3. We have 8.0 times 10 raised to the power minus 16 divided by 9.1 times 10 raised to the power minus 3. Eight point 0 times 10 raised to the power minus 16 divided by 9.1 times 10 raised to the power minus 3. We have 8.0 times 10 raised to the power minus 16 divided by 9.1 times 10 raised to the power minus 3. We have 8.791 times 10 raised to the power minus 20. Therefore, our v square is equal to 8.791 times 10 raised to the power minus 20. To calculate v, we would square root both sides. We have the square root of 8.791 times 10 raised to the power minus 20 gives us 2.9649 times 10 raised to the power times 10 raised to the power 10. I have this as 2.965 times 10 raised to the power minus 10. Therefore, the speed, which is v, is equal to 2.965 times 10 raised to the power minus 2. Our next question is taken from 2009, number 6. An electric charge of 9.6 times 10 raised to the power 4 coulombs liberates 1 mole of substance containing 6.0 times 10 raised to the power 23 atoms. Determine the value of the electronic charge. Our electric charge, 2009, number 6. Our electric charge was given as 9.6 times 10 raised to the power 4, and our Avogadro's constant. Avogadro's constant was given as 6.0 times 10 to the power 23. This is the value of the electronic charge. Our electronic charge is given as Faraday's constant divided by Avogadro's constant. And since we have 9.6 times 10 raised to the power 4 divided by 6.0 times 10 raised to the power minus 20 times 10 raised to the power minus 23. We have 1.6 times 10 raised to the power minus 19. Therefore, the value of the electronic charge given as E is equal to 1.6 times 10 raised to the power minus 19 joules. Times 10 raised to the power minus 19 coulombs. Our next question is taken from the year 2008, number 7. An electron of charge 1.60 times 10 raised to the power minus 19 coulomb is accelerated under a potential difference of 1.0 times 10 raised to the power 5 volts. Calculate the energy of the electron in joules. Given our E to be 1.6 times 10 raised to the power minus 19, and our potential difference, which is V, is equal to 1.0 times 10 raised to the power 5. But to calculate the energy of the electron in joules, our big E equals small e times V. That is our electron times multiplied by our potential difference. It is 1.6 times 10 raised to the power minus 19 times 1.0 times 10 raised to the power 5. We have 1.6 times 10 raised to the power minus 14. Therefore, the energy of the electron is equals to our E is equals to 1.6 times 10 raised to the power minus 14 joules. We've come to the end of today's lesson on Passnownow preparatory class on physics. I really hope you understand and you can familiarize yourself with more questions. Thank you. Bye-bye.